Okay, so we're diving into the world of software design patterns today, and specifically one that's known for its elegance and power, the Abstract Factory.
It's a classic.
It is. We've actually got some slides here from what looks like a C++ programming lesson on this very pattern, and let me tell you, it gets pretty in-depth. But before we get lost in the weeds of code, no pun intended, maybe we can start with the basics. What exactly is the Abstract Factory design pattern?
So in essence, the abstract factory is, well, imagine a factory that creates other factories,
Whoa, meta.
right? Each of those smaller factories then specializes in, let's say, producing a family of related objects.
Families of objects. I like where this is going. What exactly do we mean by that?
Okay, so picture this. A furniture factory, right?
Yeah.
But instead of just churning out any old chair or table, this factory is set up to produce different styles. Modern, rustic, minimalist, you name it.
Yeah.
Each style is like a family of objects, chairs, tables, sofas, all with that cohesive aesthetic.
Ah, I see. So it's not just about creating individual pieces, but ensuring they all fit together within a specific style. That's pretty neat.
Exactly. And that's one of the big advantages here. It guarantees that everything created by a particular factory just works together seamlessly.
Mm.
So instead of you, the developer, having to build each piece individually and make sure it matches, you're requesting a whole style from the factory.
And each piece, while having its own little construction details, is abstracted away, right? I mean, the beauty of this pattern, at least from what I'm gathering, is that it lets you request, say, a chair without needing to specify every little detail of its construction.
Exactly. You say, give me a chair that fits this style, and the factory handles the rest. You get the right chair, no need to specify if it's chrome and leather or reclaimed wood, the factory just knows.
Okay, so we're keeping things flexible, adaptable. Got it. Now looking at this diagram we have here, things get even more interesting. We've got three boxes at the top: Abstract Factory, Concrete Factory 1, and Concrete Factory 2, each with these methods: create product A, create product B, and so on. Then below, interfaces for Abstract Product A and Abstract Product B, each with their own implementations: Product A1, Product A2, and so forth. Can we break this down a bit?
Absolutely. So what you're seeing here, this is the essence of the pattern visualized. You've got the abstract factory up top, acting as the blueprint. It defines the methods for creating the product families.
Hmm.
Think of it like the master plan.
Gotcha.
Then we've got Concrete Factory 1 and Concrete Factory 2, which are your specialized factories, each one tailored to a style.
So in our awesome furniture factory analogy, Concrete Factory 1 could be like modern furniture factory, and Concrete Factory 2 would be rustic furniture factory.
Bingo. And those create product B methods in those factories, those would be things like create chair, create table, and so on.
Okay, I'm with you so far. Now, what about these abstract product interfaces and their implementations below? These seem to add another layer to this whole setup. What's going on there?
This, my friend, is where the real magic of flexibility comes in. These interfaces, they define the common methods that all products within a family should have. So, for example, all chair objects, no matter what style, might have a method like, let's say, sit or get material.
So product A1 could be our modern chair, and product A2 would be rustic chair, each implementing those chair methods in their own specific way.
Exactly. The concrete implementations, like your modern chair and rustic chair, they provide the specific details for each product type within that style. They're filling in the blanks while still adhering to that initial interface contract.
Okay, this is making a lot more sense now. But there's one last piece of the puzzle I want to make sure I understand. We've got the client at the very top of this diagram. What's its role in all of this?
Ah, yes, the client. This represents the part of your code that actually uses the abstract factory and all those lovely objects it creates. And here's the kicker: the client. It interacts with the abstract factory and receives these concrete products, but it doesn't need to know about the specific implementations.
It's like the client is saying, just give me a chair that matches this style. I don't care about the nitty-gritty.
Exactly. That level of abstraction is pure gold for flexibility. Let's say you decide, you know what, I want to add a new furniture style, something completely different. How about cyberpunk?
All right, cyberpunk furniture it is. What happens to our code then? Does everything just explode?
See, that's the beauty of it. With the abstract factory, you wouldn't need to rewrite huge chunks of your code. You'd just create a new concrete factory cyberpunk furniture with its own create chair, create table methods, and boom, existing code, untouched. No need to rewrite everything. Maintenance, future updates, a walk in the park.
So what you're saying is, by using this pattern, our code becomes as adaptable as, I don't know, a chameleon.
In a way, yeah. It lets your code evolve, incorporate new features, new variations, all without turning into a tangled mess.
My mind is officially blown. And to think, we haven't even gotten to the actual code examples yet.
Well, that's the beauty of it, right? The abstract factory is as elegant in concept as it is in practice.
Well, on that note, I think it's time we transition from the conceptual to the concrete. Let's see this bad boy in action with some real code, shall we? All right, so we've got this awesome diagram. We've talked about abstract factories, concrete factories, but you know me, I like to get my hands dirty. Let's see some actual code.
Always eager. That's what I like to see. Well, we've got some C++ code snippets here that'll really bring the abstract factory pattern to life.
C++ me. Nice. I'm ready when you are.
All right, so this particular example, it's centered around our furniture factory analogy, just to keep things consistent.
Makes sense. So I'm looking at the code here, and we've got classes defined for things like, let's see, chair, table, and then modern chair, modern table, Victorian chair, Victorian table. I think you see where I'm going with this. I'm guessing these represent our different furniture types and styles?
You got it. You see how those classes are structured. Chair and table, those are our abstract product interfaces. They lay down the law, so to speak, define the common methods that all chairs and tables should have, regardless of their style. So like both chair and table might have a method, say, get dimensions, but how those dimensions are actually calculated, well, that'll be specific to each style.
So a modern chair and a Victorian chair would each have their own way of figuring out those dimensions, right?
You're getting it. And that's the beauty. That's the flexibility this pattern gives us. Now let's shift our focus over to the factory classes. We have furniture factory, which, as you might have guessed, is our abstract factory. This guy defines the methods for actually creating the furniture, things like create chair and create table. Then we get to the specifics. Modern furniture factory and Victorian furniture factory are concrete factories, each one knowing exactly how to produce furniture in their respective styles.
Okay, I see. It's like our diagram has come to life right before our eyes. This is exciting stuff, but how does this code actually create those furniture objects? Walk me through it.
All right, so take a look at this line here. Factory. Modern furniture factory. Here we're creating an instance of our modern furniture factory. Easy peasy. Then we can call it create chair method like this. Chair factory.create chair. What this does is it returns a shiny new modern chair object. And check this out. We didn't have to write modern chair anywhere in that code.
Hold on. So what you're telling me is I can just swap out modern furniture factory with, say, Victorian furniture factory if I want a Victorian chair instead.
You got it. That's the beauty. Change the style of furniture just by switching out the factory. The client code, it doesn't even need to know the specifics of each furniture style. It just works.
This is incredible. We're talking about adaptable, maintainable code here. This is how you avoid those spaghetti code nightmare.
Exactly. Good design patterns, they make all the difference. Now, let's say you're building a video game. Think different character classes, warriors, mages, archers, each with their own unique weapons, their own unique abilities.
Okay, I'm already hooked. Where does the abstract factory fit in this scenario?
Well, think about it. You could have an abstract character factory that defines those methods for creating characters, their weapons, their abilities. Then you'd have those concrete factories again, warrior factory, mage factory, archer factory, each one responsible for creating the right stuff for their specific character type.
So when a new character enters the game, the code just calls upon the right factory to equip them accordingly. That's brilliant.
You're getting it. That's the essence of it. The abstract factory, it lets you create these families of objects without tying your client code to those concrete implementations. Flexibility, extensibility, manageability, it's all there.
My brain is doing backflips right now. It's like having a toolbox full of specialized builders, each one ready to assemble the perfect component for your software masterpiece. But we've been deep in the code here. I'd love to hear about some real-world applications of this. Where else does the abstract factory pattern really shine in software development? So we've really dug deep into how this abstract factory works, but I'm always curious about seeing things in action. Where does this pattern really shine in actual software development? What are some real-world scenarios where it's the perfect tool for the job?
Yeah, you're right. Getting those practical applications is key. One area where the abstract factory is a rock star is in cross-platform development. So imagine you're building an app and you need it to run smoothly on different operating systems. We're talking Windows, Mac OS, Linux, the whole gang.
Right, because each OS has its own unique style, right? You don't want a Windows-looking button just hanging out on Mac OS. That would be a little awkward.
Exactly. And that, my friend, is where our hero, the abstract factory, swoops in to save the day. So you could have an abstract, let's call it UI element factory, that defines the methods for creating these UI elements, buttons, checkboxes, dialog boxes, the works.
I'm with you.
Then you'd have your concrete factories again, but this time they're things like Windows UI Element Factory, Mac UI Element Factory, Linux UI Element Factory. Each one knows exactly how to create UI elements that fit in perfectly with their respective operating system.
So depending on where the app is running, it just calls the right factory to get that native look and feel. Seamless, elegant. The user wouldn't even bat an eye.
Exactly. The abstract factory is like the chameleon of software design patterns. Your application blends in no matter where it goes, all while your core code stays nice and clean, totally independent of those specific UI implementations.
Okay, that's really slick. Are there other cool examples of how this pattern is used out in the wild?
Oh, absolutely. Let's say you're building a web app, right? And you want to give your users the ability to switch between themes. You've got your light mode, your dark mode, maybe even something fun like a cyberpunk theme.
Oh, I'm all about that dark mode life.
Uh,
How would you implement that with our friend the Abstract Factory?
well, you could have an abstract theme factory with methods for creating all those UI elements again. But this time, they're styled according to the theme buttons, backgrounds, text fields, the whole shebang. Then your concrete factories, those would be things like, well, light theme factory, dark theme factory, and of course, cyberpunk theme factory.
Oh, okay, I'm picking up what you're putting down. So when a user switches to dark mode, the app just starts requesting those UI elements from Dark Theme Factory, and bam, instant dark mode.
You got it. And here's the best part. You can add new themes down the line without touching that existing code. Just whip up a new concrete factory for the new theme, and you are good to go.
This pattern is seriously versatile. It seems like you could use it for anything that involves creating these families of related objects.
You hit the nail on the head. It's a game changer for building software that's flexible, that's maintainable, that's ready for anything. Anytime you find yourself needing to create objects that are like siblings, they share that common interface, but they each have their own quirks. The abstract factory should be on your radar.
I have to say, this deep dive has been eye-opening. I feel like I went from Abstract Factory to understanding how it can make my code cleaner, more adaptable, basically ready to conquer the world.
That's what we like to hear. It's one of those patterns that, yeah, it might seem a bit abstract at first, but once you grasp those core ideas, see how powerful it can be, it really can elevate your whole approach to software design.
So, to all you listeners out there, think about it. How could you use this in your own projects? Cross-platform applications, different themes, or maybe you just want to make your code more organized, more adaptable. The possibilities are pretty much endless.
That's right. Keep those coding brains buzzing.
And on that note, we're going to wrap up this deep dive into the Abstract Factory design pattern. We hope you enjoyed the ride. Until next time, happy coding.